Alright guys, this is your video for volume of a cylinder. You have these notes in front of you and you're going to watch this video and fill these in and do the examples that you have. At the end of that you will have a answer sheet where you'll need to be able to work out some volume doing that as well. So you'll fill out these notes watching this video. Also attached to here, I want you to notice this is your K-Prep mathematical reference sheet, which I'm giving to you as well that you can use. I want you to make note that when you are taking a test, the formula for a cylinder for the volume is located right here on your mathematical reference sheet. So you may use this mathematical reference sheet while you're working your problems out, or also your notes for examples as well. Okay, so let's just watch the video and fill in your notes.
Hey again, Anthony here. Welcome back to Mashup Math. Thanks again for joining me on this lesson. Let's just get right to it. What's up again, everyone? Thank you so much for stopping by and for joining us as we explore in this lesson how to find the volume and surface area of a cylinder. Here's a question. What does a cylinder even look like? Well, we actually see them every day in things like paint cans, potato chip cans, and containers of lip balm. Balm is kind of a weird word, isn't it? Anyway, back to geometry. So in geometry, we have a very standard diagram for what a cylinder looks like. And we can think of this diagram as one of those objects that we just looked at, except if it was made out of glass and totally see-through. And we should also note that all of the concepts and relationships that we are going to discuss concerning cylinders apply to any and all cylinders of any size, shape, or orientation. Okay, so now our next question is, what's the deal with these things? How can we relate things that we've already learned in geometry, things that we already understand, to this new concept of cylinders? We can think of creating a cylinder by starting with a circle and creating a tube-like shape where the size of that original circle does not change no matter where you are inside the cylinder. So this is a helpful concept to understand, so let's go ahead and visualize it one more time. So now let's direct our thinking towards finding the volume and surface area of a cylinder. Now we can find both of these things using a formula provided that we have two pieces of information. That is the height of the cylinder and the length of its radius, which is the radius of the circle either at the top or the circle at the base, or really any of those circles in between that are inside the cylinder. Now we know that volume represents the amount of space inside of a closed figure. So we can think of the volume of a cylinder as how much it can hold inside, maybe if we were to fill up a bucket with green paint. And we know that surface area represents the amount of space it would take to cover up the outside of a figure, like if we were going to wrap it with wrapping paper, or maybe spray paint it with some kind of a design. So now we're ready to go ahead and familiarize ourselves with the formulas for finding both volume and surface area of a cylinder. The volume of a cylinder can be found by multiplying pi times the radius squared times the height. And surface area can be found by multiplying the product of 2 and pi and the radius by the sum of the height and the radius. And remember that volume is measured in cubic units and surface area will be measured in square units. Okay, so now we're ready to take a look at this example, which is what is the maximum volume of coffee beans that could fit inside of a cylindrical tin with a height of 8 inches and a radius of 4 inches. So next, let's highlight the key information. In this case is that we want to find the volume of the inside of a cylinder with a height of 8 and a radius of 4. So to visualize this, we're thinking about how many coffee beans can fit inside of a cylinder-shaped can. And since we measure volume in cubic units, we're actually thinking of our answer in terms of how many 1-inch cubes of coffee could fit inside of this can. So at this point, we can revert back to that simple diagram of a cylinder, and we know that the height is 8, so we can label the height with the value of 8, and the radius is 4 inches, so we can label the radius with a 4. And now we can use our volume formula, V equals pi r squared h. We can replace r squared with 4 squared since the radius is 4, and we know that 4 squared is just 16. Then we can replace h, the value of the height, with 8 since the height was 8 inches. And now all we have to do is multiply to get our final answer. Pi times 16 times 8 is approximately 402 cubic inches. And remember, that means that this can could hold approximately 402 of these little 1-inch cubes of coffee.
In this example, we're asked to find the volume of the given cylinder. To find the volume of a cylinder, we use the same formula that we use to find the volume of a prism. Volume equals area of the base times height. Notice, however, that the base of a cylinder is a circle, and remember that the formula for the area of a circle is pi times radius squared. So the formula for the volume of a cylinder can be written as pi times radius squared times height. So to find the volume of the given cylinder, since the radius is 7 meters and the height is 10 meters, we can plug this information into the formula to get pi times 7 meters squared times 10 meters. Remember that 7 meters squared is the same thing as 7 meters times 7 meters, which equals 49 meters squared. And we have pi times 49 meters squared times 10 meters, which simplifies to 490 pi meters cubed. So one way to write the volume of the given cylinder is 490 pi cubic meters. Next, remember that pi is approximately equal to 3.14. So we can plug 3.14 in for pi, and we have 490 times 3.14 meters cubed, which equals 1,538.6 meters cubed. So another way to write the volume of the given cylinder is 1,538.6 cubic meters.
Alright guys, this is your example number 3 right here, finding the volume of this cylinder. So what you do, you look at this cylinder, and there's a little something different in this cylinder. You have a diameter at this time is given instead of a radius. See, the diameter goes from one end of the circle to the other through the middle. We don't need the diameter in our equation. We need to find the radius. So what is the radius? Well, you know that the radius should look like that. And when I move my finger again, that's only halfway. So the radius is half of that diameter. So to be able to find the radius when you're given a diameter, you're going to take your diameter and divide it by 2. And when you do that and you divide that by 2, you end up finding the radius of your circle to be 77.5 meters. Okay? So now we have the radius by taking half of our diameter. We now can look and see we find the height. The height is 22 meters. And we can now use the formula for volume of a cylinder, pi times the radius squared times the height. Well, all I need to do here is fill in my information that I have. So for the radius, I have 77.5, and I'm going to square it. For my height, I have 22. And now I can be able to break it down what I have. So 77.5 squared will be 77.5, and I can square that right here. Will give me 6,606.25. I can then multiply that by 22. When I multiply that all together, when I multiply this by 22, I ended up getting my answer to be 132,137.5 times pi. Now this is pi notation, where you just basically multiply the radius squared times the height and you leave it as pi. This is called the exact form in it. But sometimes we don't want the exact form, so what we do is we use 3.14 and multiply it by this number to find our standard. So I'm going to multiply it by 3.14, and when I multiply that by 3.14, I find my answer to be 414911.75. There you have it. Thank you.